here's our definition for this week. Definition and irrational expression is an expression written as a fraction. So when we were learning about numbers, we learned about fractions, and we said that something like 1/4 or 0.25, these are what we call rational numbers because they can be expressed as a fraction. Okay, so now we're just saying, okay, well, what if we have an expression like this? So we're going to start very simple, and we're going to go back to early fractions, like the first time that we learned about fractions. And we see something like this, 4/3 plus 9/2. And I'm asked to add these two things. And if you remember that in order to add these two things, I need what we call a common denominator. Okay, I need a common denominator. So what I notice is that this denominator has a 3, this denominator has a 2. In order to get them in common, I need a 3 over here and a 2 over here, right? So that way they both have the same common denominator. But I can't just multiply the denominators, I need to multiply the numerators, and now we get something like this. 8 over 6 plus 27 over 6. Now I have common denominators, everything's good. And we get 8 plus 27 over 6, which would be 35? Yeah. 35 over 6. And at this point, we would see, like, can we reduce this 35 over 6? And we can't, so this is actually our final answer. Okay, everything's good. So I want to go into a couple examples like this, and the reason I'm showing you this is so that we start with the simple. We start with what we know how to do. And I'm also going to find common denominators a little differently than you may have been taught in the past, okay? So I'm going to go with another example, 3/5 minus 1 over 10. And so, as I said, like, you may have found common denominators differently, but this is a way that I'm going to find common denominators with these first examples so that it makes sense when we get to the harder stuff. So when I see 3/5 and 1/10, I see 3 over 5 minus 1 over 5 times 2. And I notice that in my denominators, this guy has a 5 and this guy has a 5, but this guy also has this extra 2. So if I want to get a common denominator here, then I need to multiply this by 2 so that I have that extra 2 to get our common denominator. This becomes 6 over 10 minus 1 over 10, which is 5 over 10. And last thing is, can we reduce this? 5 over 10 does reduce, and this reduces to 1/2. So our answer is 1/2, okay? So that way of finding the common denominator is how I'm going to express some of these examples. So we'll do one more. Let's do 1/9 minus 7/12. Okay. So if I'm looking at these two fractions, I'm going to break them up just how I did before. 9 is the same as 3 times 3. And 12 is the same as 3 times 4. So here's what I notice. Both functions have a 3, or both expressions have a 3, but one expression has a 4, and let's go orange. One has a 3. Like, those two don't match. So I need to make these equal. So I need to multiply by a 4 over here and multiply by a 3 over here. Now we have 2 3s and a 4 on both sides. So 3, 3, 4, 4. Okay. And now we're left with 4 over 36 and 21 over 36. 4 minus 21. If we do 21 minus 4, we get 17. So we would get negative 17 over 36. That does not reduce, so we're going to leave it there. Okay. So far you're probably feeling like, all right, National Merit Scholars, feeling pretty great. Everything's fine. I can do this in my sleep. Let's do it. So let's kind of step up the level of difficulty here a little bit. So what if I now change my fraction to be 4/3 plus 9 over x? So now I notice that this is a variable. This is an unknown variable. And as we said before, we always need a common denominator. This does not change. It doesn't matter how crazy the fraction looks, we always need a common denominator. So if I look at this expression here, this guy has a 3, this guy has an x. What do I need to multiply them by so that they have the same things? Well, this guy needs that 3, and this guy needs that x. So now when I multiply them and combine them, I have 4x over 3x plus 27 over 3x. Okay. So when I combine these, I have 4x plus 27. I'm going to fix that 7 over 3x. Remember that we can't combine these two terms because they're not like terms. Okay, they don't both have an x in common. So because of that, this is our final answer. Okay. All right. So the process still stays the same. It's just that we don't end up with a nice fraction like 1/2 in our answer, and that's okay. So let's kind of use the same, like the examples that we were using before, but we're just going to kind of throw some new stuff in there. So how about this? 3 over 2x minus 1/10. Okay. So we have 3 over 2 times x minus 1 over 5 times 2. All right. So let's see. They both have a 2 in common, so that's good. But this guy has a 5, and this guy's got an x. So I need to make sure that my common denominator gives everybody the same things. So this guy over here needs a 5. This guy over here needs a 5. This guy needs an x and an x. So what do we got? Well, we got 15 over 10x minus x over 10x, and when I combine those, 15 minus x over 10x. And there's my final answer. All right. So here's what I'm going to do for this last one. I'm going to write out the problem, and I want you to try it on your own. And then, so pause the video right now. And then once you've tried it, if you could play the video, see if your answer was correct, or follow along. All right? So I'm giving you this moment to pause the video. Well, actually, wait, not yet, because I need the problem. Sorry. So 1 over 3x minus 7 over x squared. Okay, so go ahead and pause if you would like to try the problem yourself. Okay, so here's what we got. 1 over 3x, 7 over x squared. So x squared is the same thing as x times x. And now when I go in and I see what's common, well, they both have an x in common. But this guy's got a 3, and this guy's got an extra x. So what do we need? Well, this guy needs that extra x, and this guy needs a 3. So I have x over 3x squared minus 21 over 3x squared, x minus 21 over 3x squared. And there's our answer. All right, guys. So thank you for watching this video. I hope it was helpful. And this is going to help when we go into some explanations and some more complicated examples. All right. See you soon.